We present Scrappy, an FDM 3D printing system to repurpose scrap objects as infill. Custom toolpaths enable scrap objects to be inserted during fabrication. This reduces filament use and printing time, making printing faster, more affordable, and ultimately more sustainable. Our method provides structural integrity and internal support for bridging surfaces. Simply printing without infill often leads to failed prints. Scrappy spans an entire print fabrication workflow. A web-based library tracks different kinds of scraps, like trash, failed prints, old prints, found objects, and leftover hardware. Adding scraps requires uploading a mesh, or entering dimensions for common objects and shapes. Additional metadata can be added to assist users in locating a scrap again later. Scrappy is designed to integrate into existing CAD software, like Fusion 360, as an add-in. During modeling, our inclusion engine searches for scraps in the library. And suggests good ones to use as infill. An adapted version of Jacobson's Matryoshka algorithm is used to test if scraps fit, and if so, to find an optimal position and orientation. Using the user's model and recommended scrap, a modified slicer optimizes the remaining internal infill to prevent generating internal walls around the scrap cavity. During printing, the exported machine code pauses printing with a beep-in message, alerting the user that the scrap is ready to be inserted. If supported by the printer, the system generates animated instructions to display on the printer showing how to insert the scrap, and a QR code linking to scrap details in the library, like a picture of the scrap and information, like a bin number, to find it. Ideally, scrap insertion can be done by anyone who happens to be near the printer. We use the Scrappy system to print a range of different models with different scrap types, such as a gear with a jar lid inside, a fossil token with a rock inside, and a baby Yoda with a Pikachu inside. For additional details, see the accompanying paper.